happening or that happening. So let's take, for example, Hitler's mother. Let's say a cosmic ray went through Hitler's mother. A cosmic ray is a quantum event. There's, let's say, a 50-50 chance that Hitler's mother will then have an abortion. Have a spontaneous abortion, a miscarriage. And a 50% probability that she won't have a spontaneous abortion, that she will have a full-term child, Adolf Hitler. So we now have the fact that because everything vibrates, two universes have now separated, and one universe has no World War II. All of a sudden, 60 million people didn't have to die, while the other universe is our universe. Now this sounds like science fiction, right? The only difference between this and science fiction is that the scenario I've given you comes from modern physics. This is the basis of our present-day industrial revolution. Think of transistors, think of GPS, the internet, television, radio, all the wonders of modern technology. They're all based on the idea that electrons are waves, and these waves in turn are waves of probability. And the probability can bifurcate, can fission, and universes can then emerge from other universes. So when I look at myself in a mirror, well, most people would say, I see me in the mirror. Well, I don't look at it that way. First of all, when I look at myself in a mirror, I say to myself, I'm looking at myself as I was a billionth of a second ago, because that's the time it takes for light to go from my face to the mirror and back. I'm not really looking at me at all. I'm looking at me as I was a billionth of a second ago in the past. Second of all, I'm not really well defined. I'm really a mixture of different kinds of waves. Now these waves really do look like me. If I were to get graph paper and graph these waves, by golly, they really do look like me, except for one crucial difference. Parts of the wave ooze off. It's a wave. It oozes off to Mars, to Jupiter, to outer space. Parts of me ooze in all directions. So there's a finite probability that I will go to bed tonight and wake up on Mars tomorrow. Now, of course, it's a very small probability. I can calculate it. I would have to wait longer than the lifetime of the universe for that to happen. So chances are I'm not going to wind up on Mars tomorrow. However, it is possible. And I can even calculate the probability that I will wake up on Mars tomorrow. So anyway, to answer your question, A, everything is vibrating. B, these vibrations are vibrations of probability. C, universes do separate. Universes do separate and do all sorts of crazy things. But in the main, they average out. So when I look at myself in the mirror, on average, that is me. But that's only an average. Part of me is on Mars today. And part of you is also on Mars, believe it or not. Well, Brad, you touch upon the very heart of the quantum theory. In Newton's theory, the theory proposed 300 years ago, a dot represents matter, and it's just a dot. That's all it is. These dots can reform, collide with each other, obey certain equations, but they don't vibrate. Then in 1925, along came quantum mechanics, which says that these dots of matter, the electron, the proton, are not really dots at all. In some sense, they're waves of vibration. Things are waving, and this means that our bodies are actually waving as well. This is the basis of wave mechanics, the fact that particles have wave-like properties. Then the embarrassing question is, what is waving? What is it that is waving? The answer is, and you're not going to like this, the answer is that what is waving is the probability of finding that particle at a given point. So let's now summarize it in one sentence. According to the quantum theory, matter is made out of dots, but the probability of finding the dot at any given point in space and time is given by a wave. Now, then you raise a question. What happens if you change the vibrations of these waves? Can you then drift into other universes? Can you then drift into other planes of existence? And at the atomic scale, the answer is yes.